Thank you for joining us. In this video clip, we will be discussing what makes a good phenomenon. And why is this important? Why is it important to have a good phenomena in our classroom? So as you remember, phenomena is what drives the investigations that students are doing in our classroom. And that's the reason we want to make sure that the phenomena we choose is a productive one. So the way we've been thinking about phenomena is that good natural phenomena soar. And this acronym, the first two letters stands for specific and observable. I'll start with the observable. The observable is obvious, of course, but we have to remember that we can make observations with all five senses. So I can hear my neighbor's dog barking is a great observable phenomena. Phenomena also have to be specific. So although hurricanes are a phenomena, hurricanes by itself, that word is not very specific. And there are so many examples of hurricanes that could make that more specific. And in this example, I chose Hurricane Michael, which was a real hurricane in the Gulf of Mexico that increased in strength from a tropical storm to a Category 4 hurricane in just 2 days, which was unprecedented. And when students have a specific phenomena like this, they can actually find data and information to investigate this phenomenon.
So the A of SOAR is appropriate for your grade. And what this means is we're always asking students to explain phenomena using core ideas. And core ideas in kindergarten may not be sufficient to explain a phenomenon that you want to introduce to your kindergarten students. So you have to make sure they match. So if you're teaching high school, you want to make sure the phenomenon you pick needs actually to be explained with high school core ideas. So you want to make sure it matches the grade you're teaching. And finally, the R is relevant. So you want phenomena to be compelling to your students. And if you teach in an urban setting, they've probably experienced that it's really hot on the subway in the summer. But if you teach in a rural setting, that's not going to be very interesting or compelling to them. So something that is relevant, something that's connected to their lives in some ways, or just universally cool like dinosaurs, you can always use as a phenomenon. So if we're talking about what makes, how we can present phenomena, we also should talk about ways not to present phenomena. So we don't want to be the one asking the questions. The goal of phenomena is for students to be asking questions about these phenomena, and we don't want to take that opportunity away from them.
So we also don't want to present phenomena as concepts. So for example, you may be teaching a concept that objects with densities lower than water will float. But the question we have to ask ourselves as teachers is, what is an observable example of this concept that I'm trying to teach? And one example could be that ice cubes, for example, float on water. So that would be your phenomena. We also don't want to present phenomena as processes. We teach lots of different processes in our classroom: floating and sinking, we just talked about, the water cycle, or photosynthesis. Very important processes, but processes like these are not phenomena in themselves. So again, we have to ask ourselves, what is an example of photosynthesis? So for example, when I plant a seed in the ground and I come back a year or 2 years later and this enormous plant or sometimes a tree grows out of the seed, that is the phenomena. And when students explain that phenomena, they learn about the process of photosynthesis. So thank you for being with us in this video clip, and we'll hope to see you at our next video clip where we're going to discuss how we can identify phenomena in or around our home or school.
Thank you.